Good evening, and welcome to Quiet Science. Tonight, we're going to slowly explore one of the oldest stories in the universe: how stars are born, how they live their long, patient lives, and how they eventually fade. We'll move gently through what science has uncovered, one idea at a time, with plenty of space to breathe between each one. Some of what we discover tonight will feel impossibly vast. Clouds of gas stretching across light years, fires burning for billions of years. But it will all arrive quietly, the way the best things do. If you'd like to join us for more nights like this one, you're welcome to like and subscribe below. It means the world to this little channel. But for now, all you need to do is get comfortable. Let your breathing slow. Let the universe do the rest. Let's begin. Within cold, dim clouds, gas drifts and gathers. Gravity nudges it inward, slowly, almost lazily at first, and the threads of turbulence whisper through, stretching and folding the material into strands and knots. Starlight from neighbors reaches in and softens some edges while scouring others, so that what survives are not evenly spaced seeds but sheltered clumps tucked into the cloud's deeper shadows. Here, the airless quiet is heavy, and yet the motion never truly stops. The cloud is laced with currents, and the weight of gas gives each protected region its chance to thicken. In that patience, a star's story begins, not with a flare, but with a gentle leaning together of atoms that have waited for this tug. Dust is part of this scene. Grains float in the cold, like smoke whose sparks have gone out. They hide the most fragile beginnings. They soften the harsh light from any brighter star nearby, and they hold it as warmth, releasing it later as a quiet infrared glow. Around the clumps that are growing heavier, dust is as much shield as blanket, taking the sting out of higher energy light that would otherwise strip away the thin threads of gas. Protected by this veil, the nascent centers can last long enough to grow. Wrapped in dust, a young star is allowed a gentle first breath. Across these clouds, magnetic fields thread the gas, crossing and recrossing like faint, taut fibers set into a fluid. They run through the clumps and the wider wisps, and they also reach into the bodies that will form from them. As gas gathers and falls toward an embryo star, the fields guide some of it, shaping how it lands and how it flows once it is there. When the newborn object spins too quickly, those same fields help launch thin jets of gas that lift away extra spin. They do not tear the star apart. They quiet it, allowing the striking of a stable balance later on. From cloud to core, the fields are quiet shepherds. Star birth does not fill the vast rooms of space evenly. Some places sit in long quiet, too diffuse to tip into collapse. Others get a nudge. Waves from past explosions push on the gas like slow fists, and passing spiral arms sweep extra material into certain lanes. Wherever the push is enough, Clouds compress and the hidden clumps feel it, crossing the threshold from almost to surely. Where the push is too strong, some fragile seeds are scoured back into the surrounding haze. The pattern is patchy and patient, with pockets of bloom and stretches of delay folded alongside each other across the face of a galaxy. Most newborn stars come in families. A cluster emerges when a larger cloud fragment hosts many separate infallings at once, so that siblings of different sizes light up over a shared span of time. They carry the same basic chemical recipe from their birth cloud, the same quiet flavor in their dust, though the mass each one gathers gives it a different pace of life. Open clusters are loose, their bindings light, hundreds of stars still lingering together while they age at their separate speeds. Globular clusters are compact and ancient, bound deeply, their many thousands of members still tracing the patterns of their earliest chapters across a long stretch of time. Once shining, each star pours out a spread of colors. Its light turns into a spectrum that holds a measured calm, a set of lines and slopes that quietly reveal temperature, hints of motion, and the elements mixed into the glowing gas. The color of a star is not a single tag, but a blend, yet the hue leans toward the truth. A blue-white surface means hotter, an orange-red surface means cooler, always understood as a comparison when size and distance are held still. In these colors lies the near-surface heat, and etched into the detailed spectrum lie the delicate fingerprints of what the star keeps in its light. Stars do not shine with a perfect steadiness. Their brightness tilts and rises in small ways over time, a light curve drawn in slow strokes. Rotating spots, cooler magnetic regions, turn into and out of view and make a soft modulation, a distant heartbeat of spin. Companion stars slide in front and behind, and the combined light dips in a regular sequence when one body eclipses the other. Rhythmic pulsations stir from deep within, and the surface breathes outward and inward at measured intervals. Each of these quiet changes is not a flaw, but a signature of what is happening inside and around the glowing sphere. At the center of a star's life is a balance. Gravity presses inward, hot gas presses outward. The weight of the overlying layers leans down on the core, and the pressure of heated particles pushes back. This steady equilibrium defines most of a star. It does not lean toward collapse or drift toward expansion in any restless way. It simply maintains a poised structure, all of its internal layers communicating by pressure and light. Held in this balance, the star can carry itself across ages. It stands as a rounded, burning persistence, quiet in the face of all that could tip it. The mass that gathers during birth sets the pace, A heavy star burns through its stored potential quickly. A modest star glows more patiently. Some blaze through a quick, brilliant youth. Others hold a steady light that can outlast the current shapes of galaxies. The same ingredients lead to different lifetimes depending on how much was gathered into the initial sphere. Mass is also a measure of what kinds of quiet rhythms the star can sustain, what it can draw upward from its core, and how it will arrive at its own ending. Every star keeps its pace, set by that first measure. Even quiet stars shed a constant wind. A stream of particles moves outward from their surfaces, invisible as a whisper, yet persistent. The wind shapes the surrounding space, presses into nearby gas, and carries hints of the star's magnetic moods. Some of these suns keep steady companions, and the shared pull of two bodies changes the story again. Matter can be traded between them. Energy can be exchanged. The growth of one influences the calm of the other. Elemental fingerprints linger in every beam, linking each object back to its cloud and place in galactic history. Older stars often hold less of the heavy elements, the later forged ones, than their younger kin. A forming star spins faster as it shrinks. Infalling gas tightens the figure, and the rotation quickens like a drumbeat, coming into clearer rhythm. Left unchecked, the speed would become too much. But magnetic fields link the newborn to its surrounding disk. Along those lines, gas flows leave, shaped into jets and broader winds that fly away from the poles. These outflows carry away angular momentum, easing the rate of spin, and they do it early enough and long enough for a calm star to settle. The young object does not fling itself apart. It finds a way to set the spin down, to live at a rate that allows a stable future. In the same nurseries, nearby massive stars drench their birthplaces in ultraviolet light. Hard radiation pours into the tender gas and sculpts pillars and globes, carving edges and evaporating parts of the cloud. In some corners, the push strips away enough haze to let a hidden seed gather its food more efficiently. In other places, the drive is too strong and halts a forming star by removing what it needs. One cluster's new giants hasten some births while stilling others, a kind of crosstalk that shapes the final count and the layout of what survives. The nursery's shapes are their handiwork, towering and transient at the same time. As a young star settles, heat at the center grows. Slowly, the weight of all above tightens that core until the pressure is enough to bring a new process to life. Hydrogen fusion begins. It is a quiet nuclear reaction, not a blast, but a continuous, sustained conversion that puts out energy at the rate needed to replace collapse with support. The star rests into that long stage, balancing the inward tug with the outward push generated by fusion. The details of the early veils and streams fade into a memory from the core. The central heat keeps the entire sphere poised, and the glow that began dimly in dust becomes an honest shine. The pace of fusion depends intensely on the temperature of the core. A small rise means a much faster burn, a shortness of life measured in how quickly hydrogen is consumed. At a lower heat, the same reaction runs more slowly, and the star lingers. The link is not gentle, it amplifies differences. A little more heat swells into a much quicker story. A little less heat lets the chapters run very long. The mass that decided the center's pressure writes the core temperature's value into the star's future. And once that value is set, the fusion rate becomes a strong and steady metronome, marching the object through its shining years toward change. On the surface, magnetic regions create cooler patches that drift with a star's spin. These are star spots, and they move in and out of view, tilting the light a little brighter, then a little dimmer in a steady rhythm. The pattern reveals how long a full turn takes. Early on, the turns are quick. Later, the rotation slows. The gentle wobble in light carries this story without words. Many spots can come and go, but the basic beat persists, offering a reading of age through the soft music of a rolling brightness. Inside and outside, the star is sharing its state with a regular calm. Flares and coronal mass ejections sometimes break that stillness. Tangled magnetic fields on the surface can snap and reconnect, and for a brief span the light brightens as trapped energy is released. Particles are hurled into the surrounding space, a gust layered atop the steady wind. The event is not the star's life in miniature. It is a feature of the complex field that spreads through its outer atmosphere. The eruptions end, the light returns to its quiet baseline, but the imprint on the nearby space remains a little while, a passing gale layered onto a long, calm breeze. The star goes on, glowing as before, unperturbed at its core. Further inward, faint rhythmic flickers travel like sound across a great body. Astroseismology reads these tiny undulations as waves moving inside the star, carrying the story of hidden layers and rotation and core conditions to the surface. The oscillations are small, a delicate tapping that only slightly changes the light, but they are broad in insight. Where they slow, the interior is denser. Where they speed, the internal structure allows easy passage. The core's behavior nudges their beat, telling without revealing itself directly. The star hums to itself in a register too soft for any ear, and still the tune maps its inner rooms. The outward wind that carries particles away is not entirely steady. Magnetic cycles, slow moods in the field, cause the stream to strengthen and thin over years. Layers of the atmosphere respond, expanding and contracting as the flow varies. Over long spans, this variable wind peels away outer gas little by little. With time, an invisible envelope of outflow surrounds the star, shaped by the higher and lower phases of its cycles, then broadened by the general pressure of interstellar space. The process is quiet and continuous, a kind of wearing that does not mar the shine, but gently carries substance outward into the neighborhood. In a cluster where many siblings share the same age and chemical recipe, a pattern appears in color and brightness. Stars of different masses line up along a shared curve. The ones with greater mass step away from that line first, breaking from the common sequence as they begin to change, their core fuel being used more quickly. The precise place where this turn occurs is a clock that tells the age of the group. It is a graceful departure, a single point of shared change that drifts lower in mass for older clusters, and it happens in families whose birth times are held closely together. The cluster becomes a measured poem of lifetimes at different speeds. When one star regularly passes in front of another in a close pair, their combined light dips with careful predictability. These eclipsing binaries reveal their sizes and masses with precision because the timing and depth of the dimming are set by the body's widths and orbits. The brightness comes back up as the passage ends, and later the companion may slide behind, and the light falls by a different amount. Back and forth it goes, a clock that keeps track of the two spheres. Within that rhythm are their physical truths: how big, how heavy, how far apart, quietly encoded in the alternating shallows and returns of light. In some duos, the stars are close enough that their gravity pulls a gentle stream of gas from one to the other. A thin, glowing disk builds around the receiving star, fed by the smooth fall of matter. Its light shifts and swells as the transfer waxes and wanes, a living ring whose color and brightness carry the tale of what is falling and how fast. The giver thins in the direction of its companion, its outer layers reshaped by the shared pull, and both stars live a life that is no longer solitary. Energy and mass move across the narrow space as if passing a bowl back and forth. Not all stars remain with the crowd it once kept. Some speed through space as runaways, thrown out by the kick of a past explosion or by a hard scuffle with others in a cluster. As they move, they press into the thin gas between clouds and stars, and that pressure draws out bow shapes, graceful arcs where the headwind piles up enough to glow. The star continues forward along its line. Behind it, the trail is not a smoke but a shaping, a curve in the medium that it traverses. Forward motion turns into geometry, a mantle of shocked gas bent around the bright traveler. Cloud dust stands between stars and changes their light. It dims and reddens a passing beam, a soft veil of complex grains that scatters and absorbs in ways that alter color. The star is still itself, but the path its light takes shifts what arrives at distant eyes and instruments. The shape and structure of that dust matters to anyone reading the colors. Correcting for the veil is essential to recover the true brightness and hue. The cloud keeps its secrets longest where it is thickest. Where it thins, the originals come into cleaner view. The balance between concealment and truth lives in those floating solids. Chemical patterns in long-lived dwarf stars are durable. The surface holds a memory of the gas from which the star formed, a quiet record of past enrichments and the slower buildup of heavier elements in a galaxy. When groups of such dwarfs move together, their shared patterns mark older family ties, mergers from long ago, steady accretions, slow minglings that have changed the city of stars across ages. These are not quick entries written over, but notes written once and left for long readings. In their spectra, the past is present, a whisper of how their clouds were mixed, what ashes were stirred into them before they lit. High-energy light from massive stars creates rooms inside the wider medium. Photons with strength enough to strip electrons carve out hot bubbles that grow and press against their cooler neighbors. The bubbles expand, the edges curl, and mixing begins. This changes where fresh stars can form next. Some ridges are thickened and pushed toward collapse. Others are thinned and left as openings. The hot and the cool do not live side by side without touching. They shape one another's boundaries. Out of that shaping comes a new patchwork of possibility, traced by arcs of gas and shells of higher temperature that keep rolling outward until they lose their push. Rotation and mass together sculpt the face of a star. When spin is fast, the equator bulges slightly outward under the centrifugal easing of weight, while the poles draw a little nearer to the core. The surface does not hold a single temperature then, and a gradient appears from pole to equator. A heavy star feels these effects differently than a modest one, but the principle is shared. Structure, spin, and internal heat make weathered but regular baskets of light and shape. The form is still mostly a sphere, yet not perfect. And the light carries evidence of the tilt and speed with which the star turns. Some of the hottest, fastest spinning stars release matter from their equators, building thin, glowing disks that orbit close in. These rings are not thick like planets' paths, but wisps whose shine adds extra colors to the star's light. The detail of those colors reveals the rapid rotation and the direction of outflow. delicately bending the spectrum toward lines and hues that would not be there without the disk. The star maintains its spin, the disk feeds and dissipates, and now the whole system must be considered in understanding what the light says. It is a nearly edge-bound phenomenon, produced and held by speed. In places where stars form with fewer heavy atoms mixed into their outer layers, the evolution is distinct. At a given mass, these metal-poor stars are bluer. Their outer regions block less light. The difference is subtle in small measures, but meaningful over a star's life. Paths on color and brightness are altered, and the shapes and timings of later changes are offset from what would happen in a richer mix. This is not about a single species of atom, but about the gentle thickening of the outer thickets of gas and how easily radiation escapes them. With fewer blockers, the light moves out with less hindrance, and the surface tells on the difference. In some pairs where one star has already ended its central fires, a white dwarf remains as a compact ember the other star allows. The dwarf can sip gas from its neighbor, drawing a film of material onto its surface. Sometimes, when enough gathers, this new layer ignites in a brief flare, a nova that brightens and then fades back to quiet. The white dwarf remains an ember through it. The event is a surface fire fueled by borrowed matter, not a rebirth of its center. The pair continues, altered a little at the edges, the trade of material both careful and consequential over long walks of time. When a massive core collapses, neutrinos race outward almost instantly, streaming through matter with almost no interaction at all. Light, trapped and slowed by opaque layers, takes longer to work free. Before the illumination flares, the nearly invisible particles have already gone, a ghostly herald that will only be caught rarely and with difficulty even on Earth. Their near immediacy says something about the density and dimness inside the moment of change, and their tiny count at distant detectors is a testament to their easy passing through most anything. They are fast not in speed alone, but in their freedom from hindrance. At the gentle end for many stars, a central ember is left as outer layers drift away. The shapes of those shining shells vary: rings, hourglasses, more complex symmetries, and in their forms are hints of guidance. Hidden companions or magnetic fields help steer the outflow, tightening a stream here, broadening one there. The gas is not flung but released, a final exhale that keeps its order as it moves into surrounding space. The patterns are written in light, delicate and brief on a stellar scale, then gone as the thin shell spreads and mixes with the medium that waits to host some future birth. Some stars do not simply keep time under their own skins. They make a rhythm for others to measure across the depths. These are pulsators with regular expansions and contractions, a repeated swelling and settling that modulates their brightness in cycles so steady that the period itself links to overall brilliance. With the beat stitched to absolute light, the measured time becomes a way to know distance across galaxies. The star is both actor and metronome, holding to a period that tells its scale. Nothing rushes in these cycles. They roll on with such regularity that whole maps of space can be paced from their patience. With precise stellar motions recorded across the sky, the fate of clusters becomes visible as a quiet dispersal. Gaia's measurements trace siblings drifting into the broader sweep of the galaxy, long after their birth clouds have lost their edges. The common paths and slight separations map family trees, threads of related bodies unwinding into the bigger tide. The picture is one of continuity. The clusters do not vanish, they dilute, and yet their shared movement keeps their kinship readable for a long while. In this way, groupings and their dissolving are not just one-time events, but part of a larger, patient flow. In ancient clusters, a few stars stand out as unusually blue against an older crowd. They look younger than their neighbors because they have gained fuel, either by merging or by drawing material from a companion. The added mass rejuvenates the core's balance, shifting color and brightness back toward earlier stages. The cluster holds these blended lives alongside its elders. Their presence is not a contradiction to age, but a record of continuing interaction, of close passage and shared matter rewriting a few individual stories. The overall group remains what it is, old and compact, while a small number shine with a fresher cast. The surfaces of many stars are not smooth plates, but moving mosaics. Convection carries hot material upward while cooler gas sinks, and these slow upwellings and downwellings transport energy through the outer layers. The mix also stirs elements, bringing some to the surface and cycling others downward. In the detailed spectrum, the result is a set of subtleties, small changes in line shapes, tiny hints that the surface has been turned over. The pattern in brightness gains an irregular flicker from the rise and fade of granules. It is domestic work on a stellar scale, heat carried by the labor of lifting and lowering parcels of gas. Deep in the center, the long arithmetic of fusion gradually builds helium. As hydrogen combines, the ash accumulates, and the internal structure of the star shifts. The change is not sudden. It is a slow rearrangement, a careful addition that stiffens some layers and softens others. Over time, the building helium core alters how energy moves through the star, and the surface may swell or the light may brighten in response. Aging does not announce itself with a sharp sound, but with these adjustments, pressure and heat finding new balances as the central composition grows different from what it was. At the smallest masses, red dwarfs are thorough. Their interiors mix so completely that fuel does not sit unused in quiet layers. Instead, the whole star is stirred over and over, bringing hydrogen into the center while ashes are spread outward. The result is a patience unmatched elsewhere. Their fuel can last for trillions of years. They become the universe's most enduring lights, steady and uncomplicated in their habits. The timescales are beyond the current chronicles of galaxies, and still they glow, slow breathing in deep red. Technically modest, these are the keepers of time, content to go on at their set pace for epochs. The biggest stars, the ones that begin life with a great weight, cannot hold on to all they were given. Fierce winds strip away mass, flowing off their surfaces under the push of their own powerful light and fields. As the years move, what remains is not simply the start measured down, but a life reshaped by loss. Later choices and changes do not depend solely on birth mass, but on what has been shed along the way. The history of the wind becomes the sculptor of their aging, and different paths open or close depending on how much the outflow has eaten away at the original figure. In some binaries, the mutual tugging of gravity creates a tide in each star, and over time these tides synchronize spins and orbits. The rotation slows until it matches the orbital period, and the magnetic activity shifts in this new regime. Compared to single stars of similar mass and age, these bound pairs can show altered moods on their surfaces, changed levels of flaring and spots tied to the tidally set pace. The whole system moves as a linked clockwork, each body feeling the presence of the other not just as a distant pull, but as a guide to its turning. When stars swell into giants and then let their outer layers drift, they leave more than emptiness in their wakes. Dust condenses in the cooling flow, grains seeded in the gentle outpouring. Those solids become part of the nearby space, ready to be drawn into future clouds. Dust helps those clouds cool and fragment more easily, supporting the tiniest compressions that might become the next generation's clumps. The circuit is modest and continuous. Material from evolved giants enriches a neighborhood, and some of that enriched mix enables quieter, smoother collapses later on. Even endings contribute to beginnings, adding fine particles to the common store. A star and company does not simply circle. Its light holds a motion that shows the orbit in another way. As it moves toward and away around the shared center of mass with a companion, its spectrum shifts in tiny amounts, the colors wobbling. The changes pass through regular cycles, growing and shrinking as the orbit advances. Even if the companion is faint or hidden, the main star's light reveals the motion through these minute alterations in wavelength. The orbit is thus sketched not as a line on a page, but as a gentle leaning of colors first this way, then back. Many stars flicker in ways that resist regular counting. On their surfaces, immense convection cells, granules as wide as continents or larger, rise, cool, and sink. Each has a life quilt the surface in a dynamic patchwork. As these cells appear and fade, the brightness changes slightly and without a fixed period. It is not a failure of order, but the natural variability of a slow boiling lid. The flicker is irregular, soft, like the movement of a calm but living sea catching light differently from moment to moment. Underneath it, the star's deeper beat continues unbroken. Shock waves from supernovae travel far into distant clouds of gas. When these pressure fronts reach a nearby region, they compress parts of it and sometimes spark new star birth. Elsewhere in the same cloud, the waves stir turbulence and delay collapse, lending a restless energy that keeps clumps from gathering. The legacy of a dying massive star is thus twofold: the push to begin and the motion that postpones. Across a galaxy, these ripples become part of the mosaic of triggers and temperings that end up setting where and when new family clusters appear. One story ends, and the medium is changed into readiness and motion. For many young stars, the same magnetic field that guided early flows continues to shape the spin. Magnetic braking carries away angular momentum through the star's winds. Over tens to hundreds of millions of years, the rotation slows. The star's spots reveal this as they take longer to return into view, and the general level of surface activity calms. The change is not painful. It is an easing, a settling into a more sedate turn. The wind keeps its quiet work, and the magnetic ties join the surface to the outflow in a way that keeps drawing spin energy out to the wider space. In very close pairs, later stages bring a still more intimate phase. The outer layers of one star can expand enough to briefly wrap both bodies in a shared envelope. Drag within this common shroud robs energy from their separate motions, shrinking the orbit. What was wide becomes tighter, setting the stage for dramatic changes later on. The shared time is not long, but it is consequential. The envelope is shed, the pair emerges, and the distance between them has narrowed. Afterward, their path together is altered, and the possibilities that follow are changed by that brief embrace of gas around two hearts. Most stars arrive at a simple, quiet ending. After their central fuel is used and their envelopes are lost, they settle as white dwarfs, Earth-sized embers, dense and calm. No fires burn inside them anymore. They cool for billions of years, a procession of soft colors that fade toward near invisibility. Their gravity keeps them compact and round, and their earlier storms are over. In the darkness between bright stars, they are a population of almost silent conclusions. The glow they still give off a remnant of their once vigorous cores. With time, each one becomes less and less until there is only a low heat left. Some stars end differently, the weight of their cores squeezing past any ordinary resistance. Neutron stars remain where once a full-sized sun stood. They too begin hot, and they too change as ages pass. Their heat drains away, their spin slows. Those that beam in sweeping pulses do so because of a strong magnetic field that turns stored energy into a lighthouse-like signal, and even that fades. Over time, the pulses grow farther apart. The field surrenders what it held, and the star grows quieter. What is left is still, compact and reserved, a cinder of extraordinary density letting go of its motion. From the heaviest beginnings, black holes are left when collapse goes too far to resist. They persist quietly unless they are fed. If matter falls toward them, the friction and heating of that fall make a glow, and the swirls of nearby gas move in demonstrative ways. Otherwise, there is little to see. Their presence is betrayed by motion at the edges, by neighbors acting under a gravity too intense to belong to any ordinary sphere. Without a meal, even that signal grows faint, and the black hole is a dark persistence, the end state of a path walked by only the most massive of stars. The communities that star birth makes also arrive at their endings, though not abruptly. Open clusters drift apart over hundreds of millions of years. Their once tidy gatherings smear into the spiral currents that surround them. The loose binding that held them from the start is not enough to keep them together forever, and they blend back into the population at large. In those wandering stars, the chemistry still links them, a shared signature that does not dilute as fast as positions do. Even spread wide, they carry the echo of their origin in a single cloud. Families, even dissolved, keep a scent of their birth. Globular clusters endure longer. Their hearts are dense, reshaped over eons by many small encounters. They are not immune to loss. Stars still drift away, slipped from the edges by steady tugs and gentle escapes. Yet the main body persists, an old, compact city with a continuing life. Within it, the long arc of evolution plays out in crowded neighborhoods. The shared age lets their combined light trace early chapters of the galaxy, like a chorus still singing from the origin of its members. They remain as durable beacons of what early times were like, even as their ranks thin at the margins. Where populations settle as white dwarfs, their cooling tracks become sequences that reveal rich ages. In many clusters, the sorted rows of fading embers suggest ancient timescales, a record that shows the galaxy has harbored long, steady star formation with stretches of quieter lulls. The embers cool in order, stepping down in color and brightness with a calm that can be read as a timeline. Each faint light is an end, but in groups they become a narrative, a mapping of when stars were born and how a system's pace changed. Cooling, they still speak, not with fire, but with the measured hush of heat slipping away. Each cycle leaves something behind. Stellar ashes enrich clouds modestly with every generation that passes. A fine dusting of new atoms that change the next mix. Later stars carry clearer chemical stories of many earlier lives, their light marked with hints of what has been burned and blown before. The enrichment is not loud or sudden. It is accumulated, a small addition each time, building a complexity that spreads through the medium where new clumps are waiting to become. In this way, the galaxy gets flavor, and the ensuing stars keep those flavors in their beams. Across the sky, spectral fingerprints weave a wide history of motion and mixing. The lines and colors turn the galaxy into a readable archive of stellar lifetimes, a library not printed in ink but carried in the shapes of light. Motion is stitched into shifts of hue. Composition is inscribed into the spacing of absorption and emission. The layering of all these markings, old and new, heavy and light, fast and slow, becomes a map of how the city of stars moves and evolves as a whole. Even in quiet, the archive is active, being written continuously from every point that shines. Light does not arrive instantly. Because of that, stars at great distances show younger eras, their life cycles paused at earlier stages from the point of view of this present. The galaxy and the space beyond it hold the story of birth, life, and ending at many stages all at once. Some are only now gathering, some are steady in the long balance, some are drifting into embers or have already left compact remains. It is all present together, layered in distance and duration, a grand view in which times flow beside each other. The whole is not one scene, but a tapestry hung in depth. Far ahead, the changes come to their own rests. The longest-lived red dwarfs will dim into quiet embers, their patience finally running into the same calm that white dwarfs entered much earlier. The shared light of the galaxy will soften. Brightness will thin toward darkness, not with a crash, but like a day that never ends, extending its twilight out so far that it becomes the dominant state. The pace remains unhurried. Each object is allowed its time to let go. The outcome is not a void, but a room in which glowing has been set aside, and what remains is the gentle memory of how the stars once kept their patient fires. Cold, dim clouds hang in the galactic lanes, gas drifts, Dust rests in the dark, grain by grain, like powder on velvet. Gravity nudges, small at first, then steadier. Turbulence wrinkles the cloud. Threads cross, hollows gather. In some corners, neighbor starlight presses and carves. In others, shade holds. Dust soaks up the harsh shine from nearby giants and lets it out again as a soft, slow warmth. The cloud glows in infrared, like a banked ember with no flame. Hidden, a faint star-to-be turns in its cradle. It is wrapped, it is quiet. Magnetic fields thread the cloud like invisible scaffolding. They curve through knots of gas. They anchor young stars to their disks. Along those lines, matter slides and thins. Twin needles of light form where jets escape. They point away into the dark, narrow and sure. Birth spreads unevenly. A wave from a past explosion crosses one flank of the cloud and squeezes it. A passing spiral arm gathers another. Some pockets go still again. Others ripple and fall inward. Most newborn stars come with company. They collect in loose gatherings. Siblings share the same dust, the same recipe. Their first neighbors are kin. A little cluster brightens the cloud from within. A star's light, passed through a slit, lays itself out in a calm fan of colors. The pattern holds secrets without hurry. Blue-white marks heat. Orange-red marks coolness. The lines inside the rainbow carry the elements folded into the glow. It is all there, quiet, patient. Gravity presses inward. Hot gas pushes outward. The two meet at a soft, even place. A stable star holds that balance for a long, long while. The pace is set at birth, quick for some, slow for others, almost unending. Dust hides the young and protects them. It dims the harshest rays and keeps them warm. The veil glows gently on long wavelengths. Behind it, seeds of fire rest and gather. A forming star shrinks and the spin tightens. The faster turn would fly apart, but magnetic threads link the little star to its disk. The linkage tugs. Jets and winds lift away just enough spin. The whir settles. Two narrow beams stitch the darkness, thin and straight as pins. In the nursery, a few massive stars throw out strong ultraviolet light. The light sculpts. Pillars rise where gas resists. Edges glow. Faces of stone and smoke look into the brightness and then slowly evaporate. Shadows behind them hold small, protected clumps. Quietly, a young star sets a fire in its heart. Collapse eases. Pressure meets gravity and stays. The glow steadies. There is no blaze to see, only a new patience, deep inside. A small rise in the inner heat quickens the burn. A large one more so. Some stars race, some stars idle. Their lives sketch these choices in light. Dark star spots gather on a surface and drift with the spin. They face out, then turn away. Brightness rocks up and down in a soft swing. The rhythm is slow. It changes with age. Magnetic tangles snap and realign. A sudden flare blooms at the edge of a star. For a moment, the light lifts. Arcs of particles rise and sweep outward, billowing through the surrounding space. Then it is quiet again. The surface rests, mottled and warm. Inside, waves roll. They cross layers no eye can see. Their echo rides to the surface as tiny, regular flickers. A measured tremble. A star hums to itself, low and persistent. Winds slip from even the calmest stars. Sometimes they lean strong. Sometimes they thin. Over years, they take a little of the outer air with them. The edges soften. The atmosphere relaxes and drifts away, little by little. In a cluster, the heavier siblings wander from the family line first. Their path bends off, high and blue. The rest keep to the shared curve. The shape of the cluster's light shifts as the brightest depart. The group's age hangs in that bend. An open cluster floats like a scatter of seeds, a few hundred lights at most, bound for a time, then slowly loose. The night around is wide, and the cluster breathes it in. A globular cluster is different. It is compact, weighty, antique. Hundreds of thousands of lights share one small sphere. Their glow is dense and old, like honey held in a glass. Two close stars cross each other from time to time. One steps in front, and both grow dim together. The dip is smooth. The dip returns. A clean, soft blink inside a long, steady shine. When a companion draws near, gas can flow in a quiet stream. It curls into a ring around the receiving star. The ring warms and glows. Its light waxes and wanes as the flow changes, like a tide with no shore. Some stars leave home fast. A gravitational push, a past blast, a close scuffle in a crowd, and they are flung. They run through gas and dust ahead of them, piling it up into arcing shocks. Their passage writes a curved bow in the medium, like a ship at dusk. Dust, when it lies between, mutes a star. It turns white to amber. It thins the shine and leaves a gentle redness in its wake. A soft veil over a distant flame. Old, small dwarf stars carry the chemical notes of their birth clouds. Their long lives seal those notes in place. Later wanderings do not erase them. The stories ride along in the light, quiet and compact as a memory. Where giants shine in youth, their high energy glow carves bubbles in the cloud. The hot hollows expand. They meet cooler places and stir them. New places to fall together appear, and new hollows to rest in as well. Some stars spin so quick they bulge at the middle. The poles stand closer in. The belt glows a little different than the cap. A bright sphere leans into an oval, subtle and smooth. Others cast off a thin disk at their equator. The ring is faint, but it shines. It adds a whisper of color to the main light. A hairline circle, delicate as glass, in wide stretches where heavy atoms are scarce. Starlight runs a touch bluer. The glow slides toward cool silver instead of gold. The same weight, a cleaner flame. A white dwarf with a neighbor drinks a slow sip of gas. A little pile gathers on its small, hard surface. Then it ignites in a flash. The light jumps and falls again. The ember returns, unchanged at heart, quieter than before. Deep crashes in heavy stars drive ghost-like messengers outward. They leave almost at once. Light waits in the crush and works its way through. The messengers slip free and go on, heedless of the crowd behind them. As some stars let go near the end, they shed shells in calm, bright shapes. A ring, an hourglass, the hint of wings. Colors hang in space, skeins and bands, thin and clear. A hidden partner or a stubborn field can guide the flow, and the patterns mirror the guide. A few stars breathe with a faithful beat. Their swelling and settling keep time with their glow. The cycle is even. The span of the breath tells how bright the heart is. A cosmic metronome, slow, exact. Over ages, shared families stretch and fade. The motions of their members trace slow arcs away from the common birth knot. Threads unwind across the disk. The shape of kinship remains in the paths long after the cloud itself is gone. Very old clusters hold a secret bright few. They burn bluer than their neighbors. They have taken on extra fuel by merger or gift. Among the golden rust, a scatter of youthful blue holds fast. On the surfaces of many stars, convection tiles the face with rising and sinking cells, each one vast, each one brief. They lift, cool, and fold away. The surface flickers as they trade places, a fine, restless grain. Helium gathers in a core as time accumulates. The center grows weighty. The outer layers billow a bit. A star swells, or brightens, or both, like a flower open wider to the same day. Small red dwarfs mix themselves through and through. Their stores last and last. They glow cautiously, holding their fire close. They wait out eras. They are the patient ones. Huge blue stars shed mass in vigorous winds. Their edges spray into space. What remains inside and what is lost outside steer the steps to come. The shape of their later days depends on this slow unburdening. Close pairs may learn each other's pace. Tides reach across the gap. The spins slow and lock, and both turn together. Two lanterns twinned, calm and steady. A swollen giant lets go of dust. Grains cool in its breath and drift into the neighborhood. Later clouds catch them. The seeds help new pockets chill. More places for the next lights to bloom. A star's color shifts a little back and forth when it waltzes with a companion. Blue, then red, then blue again. The swing is tiny, and it repeats with the orbit. The spectrum rocks like a cradle. A shock wave from a supernova crosses an old field. It gathers some knots together and scatters others. The front compresses and ruffles as it moves. Behind it, a changed map of chance. Young stars give up their extra spin to their winds. The give is slow, not sudden. Over long tens of millions of years, the turn softens. The music of the field calms. In a very close pair, both stars can slip into one shared shroud for a while. The cloak drags on them, and the gap between them shrinks. When the cloak lifts, they are tighter than before. The stage is set for drama still to come, though for now, their light is quiet. Most stars end as embers. A white dwarf holds the mass of a star inside a world-sized form. It cools for billions of years. Its color falls from white to red to black. It fades toward invisibility, patient as stone. Some cores pack tighter and spin. A neutron star keeps a strong field in a brief day. It cools, and its lighthouse pulses slow. The beam misses beats in a rhythm stretched by time. The pause grows. Where the heaviest lives collapse, a black hole remains. It is quiet unless it feeds. Then a whisper of matter spirals in and warms, and the nearby space answers with a thin, heated glow. Otherwise, only the motions around it speak. The center itself says nothing. Open clusters do not last. They drift apart over hundreds of millions of years. Their stars blend into the galaxy. The common chemistry stays in the light, like a signature folded into the beam. The family remains, written there, even as the kin scatter. Globular clusters endure. They hold their ancient lights in close quarters for a long age. Yet even they let go. A star leaves here, a star leaves there. Countless quiet meetings in the heart reshape the pack, slow and sure. In many old gatherings, the faint white embers line up by temperature and time. The sequence of their cooling marks deep age. It speaks of long, steady making, touched now and then by a softer lull. Rows of dim points tell this without hurry or sound. Ashes from a generation lift into clouds that form the next. Not much. Enough. The new stars carry clearer stories of the many lives before them. They shine with a slightly richer light. Across the sky, colors split into patterns. Lines cross the fan of each spectrum, thin and certain. Together they weave a record of drift and mixing. The galaxy holds this archive in plain starlight. Farther light left earlier, the dome holds many times at once. Young places and old places stare past each other in the same wide field. A life cycle unfolds together in one grand view, step by quiet step. In the far future, the smallest red dwarfs go on and on. Trillions of years pass. Then even they dim into embers. The galactic glow softens toward black. A cold, dim cloud forms somewhere. Even then, gravity keeps its quiet work. Dust drifts. Magnetic lines curve through the dark and through the waiting gas. Stars are born, live, and fade. Clusters form and dissolve, and ash becomes seed. Light carries the story, and the sky keeps it quietly. And slowly, the story rests.